Hello guys, I'm back, man. I'm pretty excited for this project. It's like we are starting our mega project, but only one version of it. Actually, the whole project is the mega project, but actually we are creating a little part of it and deploying it first to see how it works. Then we'll add other features. First, we are going to create BraTS, that's brain tumor analysis. Brain tumor segmentation. Uh, so for now, we are going to experiment on BraTS and see how segmentation works, how much is the accuracy, how good it works, and all these things. Uh, so let's start and let's see how things go and how things work out. So first we have to download the dataset from Kaggle. I have already downloaded it and also extracted the files using WinRAR, or you can also use the Windows extractor. Windows have a built-in extractor. So you can use WinRAR, you can use Windows extractor, it doesn't matter. So first I want to show you the BraTS dataset. It's the BraTS dataset have two folders, BraTS training and BraTS validation data. The BraTS training data, there are a total number of 369 patient images. So these are images of uh, with labels done by doctors of various hospitals and institutes. So when we open image, we can see there is like seg 369 flare, 369 seg, 369 t1, 369 t1 ce, 369 t2. So all these things have different meaning. 369 segmentation is the label, actually the label, that's the ground truth, that's the image that are approved by doctors, that are given by the doctors, using which we are going to train our images. So train the computer how to segment the images using that label as the reference. So these are the different different modes of brain pictures. So this one is T1, T1, CE, T2 and flare. Actually, if I have to explain these modes, I have to open the metadata, but I can't find the metadata file. Oh wait, I can find the metadata file. I can go to Kaggle and find the metadata file. Kaggle. I think this one is the link. No, this one, not this one. This one is having some problems in the dataset, and the dataset is also not used much. So I will not use this one. I think, yeah, this one is the dataset. Yeah, we can see here. Yeah, the T1, all the files are in Nifty files formats, and T1 is the native data. T1 CE, yeah, T1 GD, or anything you can say, T1 CE or T1 GD is the post contrast image. T2 is the T2 weighted image, and flare is the T2 fluid attenuated inversion recovery. So these are all medical terms, so I will not go very much into it, but these are all that we have to know. And one more thing that I have to tell, that is the image from BraTS 355, right? You can see BraTS 355. The segmentation, the file in the segmentation name will be different. Okay, there is some error, maybe there is some filing error. So file naming error. So please change it and write according like this, like any other folder. You can see any other folder, it's written like this with the name. So change the 355, sorry, this is the 335. Change the 355 to BraTS 20 underscore training underscore 355 underscore segmentation, because we are going to write a generic code to detect all the file names. If we keep it like that, the code will not be able to detect the segmented file for 355, and will skip that file, and that will affect our training process. So this is all about the dataset. Now we have to move forward to the coding part. So this will be a quite long video. I'm not kidding about this, because it's a big project, and last time C400 I didn't show you how to write a code. I just went on and explained that thing, but now I have time to make you understand how to write the code. So what we'll do, we will learn step by step. Remember something, while writing the code you might face error, so we should not be demotivated by the error. Why the error is coming, we have to see that, and then maybe take the help of the internet, maybe search ChatGPT, Gemini, anything. So solving the error is the more important part than, I mean, getting demotivated and stop coding right there. So we will see how to face errors, how to, I mean, sometimes I get sometimes people say that how to know which modules we have to import. We don't have to know that. While writing the code, we might see that this module might be needed. Then we will go up and import that file. Not that I know everything what we will need in the code and importing it everything at one time. No, I am importing it step by step. So let's start the coding and we will know how to do it. So first I will go to Anaconda prompt. Then conda activate my environment. Tensor GPU. Then Jupyter, notebook, and here's Jupyter notebook. Okay, then we'll go to OneDrive. We'll close this one, desktop, projects, BraTS code, and start a new Tensor GPU file. This is our coding environment, right? So we'll name this like code one. Give it a name of the file. Then we will start coding. So first, what we have to do, in images we are dealing with NumPy arrays. Okay, first we have to see that in which format our images are given. Our format is .nii or Nifty files. So for Nifty files, the compulsory to read the files, like previously we have to unpickle the files in Cipher 100. Here we have to import a Nibable that helps us to extract Nifty files. Okay, so firstly we have to, as images are always arrays, are 2D 3D arrays, so the first thing we have to do is import NumPy. Okay, as np. Next, what we have to do, we have to import Nibable as a nib. Okay, next what we have to do, we will import one more thing, that is matplot.lib, because to show the images, because these are all images, right? To show the images we have to always import matplot.lib. So import matplot. We can import this later on, but just for like we know we need these things, so we are importing this right now, but we can also do that later. That's not something that will stop the coding from the first, because matplot.lib will not be needed right now. It will be needed when we extract all the images and all those. So we are going that in the later part. Yeah, so I think we have to run all these things. Yeah, so sometimes there might be an error in Nibable showing that Nibable is not. So if that error comes, just write this part. I'm going to show you. Just write this. I have done this kind of projects earlier using Nibable. So first time I remember that I had to do this pip install Nibable. Nibable. Write this one. So this will install Nibable and then you will do it as required. Okay, so we don't need this, so we'll keep it right here. Then we'll just add a writing that importing necessary modules. Okay, so this is done. Next, what we will do, we will import the paths of training and validation dataset. So we will import the paths of next let us give us a heading writing that we will first we will visualize the data set to make a better understanding. So what we'll do, we will visualize the data set, visualize the images. Okay, so it may be in matrix form, we'll see that later. First in matrix form, then we will go to matplot like in image format. So first what we will do, we will training path. First let's write path, just write path Then writing such comments helps us to debug later on when some error comes, when you have to change any parameter from in between the code. So for these reasons we write such comments, else we don't need such comments. Training path, okay. So next we will write train path is equal to, so our code is in code, I mean our code is in this folder. So we come back to BraTS folder, then we go to dataset folder, right? So dataset, then we go to training data, this one, right? So copy this and paste it here. Then we go to this one, MICCAI. Okay, we could have avoided this folder, but still, yeah, we're keeping it here. Then we are going to, yeah, I think we have reached, yeah, we have reached these like folders of the images. So I think we can close it here. Yeah. Next what we will do, we will add another and mark down validation path. Path. The same, sorry, same thing will be there, just the difference is for this thing I think there's validation, and for this thing, I'm sorry, there's validation again. Am I wrong? Validation, yeah, validation, same. Okay, so I think this should again run. Yeah. Next what we will do, next we will load one image. Yeah, first see that what, first let us load one image, just simply load one image. Let's see what happens. So let's load one image and check its shape. Yeah, so what we'll do, load an image. So when we're talking about an image, we are talking about a person's image. So for example, here we are taking this one, this is the first person whose image we are taking. Then we are having 2 3 4 1 2 3 5 files. We are not going to take segment because it's the ground truth. Either we taking T1 T1CE, T2 or flare. So first let us take T1, load image, and then we are going to take flare, train path, T1. So did I say flare? No, we are going to take T1. We'll not take flare. We'll take flare later on, just for checking. We are going to take T1. Okay, so for T1, what we will do, we are going to, now we are going to, this is a .nii file. We can see this is a .nii file. So we are going to use to extract, we are going to use nibable to extract this file. So as we can see, it's .ni, we have imported nibable as nib, nib. So we are going to write nib.load, nib.load train path plus, now we have reached that path, then we want to write and this. So not exactly this, the whole thing. Yeah, I think this should work. Yeah, I think this should work. yeah, dot get underscore f data. This is the whole nibbable. This is how to extract nibbable files, right? So yeah, I think this should work. Yeah, it's working. No error is coming, that means it's working. So let us see the shape of this file. The shape is train underscore path underscore t1 dot shape. Sorry. Yeah. So it's 240, 240, 155. Yeah. What does this mean? Generally, image is a 2D matrix, so there will be a length, there should be a breadth, but there is a depth in here. So what does this mean? So when we do a CT scan of CT scan of a brain, we don't take one image, we take a number of images, and these are slices of images, and then we put together. This is like a 3D image. It has a length, it has a breadth, and it has a height. So the length is 240, the breadth is 240, and the height is 155. So this is a 3D image. That's a nice thing to know. Quite nice. Then what we'll do in every case in any image processing code, we normalize the image, that is putting the max and the mean value between 0 to 1, right? So let us see what is the maximum value here. So train underscore path dot max. Sorry, did I? Yeah, t1. Okay, the maximum value is 678. That's nice. So we have to reduce that value to 1. How can we do it? We can use one thing. We can use min-max function. So the min-max function, min-max scalar actually. So the min-max scalar is a function of sklearn. So what we will do, we will import one thing. So sklearn dot pre-processing. So again there will be a question that how to know from where we have to import. Just search Google. Okay, I know this because I've been using it, so that's how I know. If you think you don't know it, just search Google. There's no issue because one cannot remember so many modules. If someone has practice, that's a different thing, but if you don't have practice, there's no issue. The main thing you have to know is to write Python code. So yeah, these are just simple things. You can Google it. So import min-max scalar. Min-max, I think I forgot the module. Just wait, min-max scalar. Let me write how to write it. Yeah, min-max scalar. This is how we write it. Okay. Yeah. Here, what we'll do, scalar. We can name it is equal to writing the module name as min-max scalar. I think this should work. Yeah. Now what we will do, we will normalize the image, right? So what we will do, we will just sec. Normalize images. Okay. So what we'll do, we can do again, bring it here. Why we are doing this? Just bring it here. There is no such reason why we are doing this. Just bring. Let's bring it here. Then what we will do, we will. I think we just all the left. We have to just normalize it. Do we have to do anything else? I don't think so. No, I don't think so. We have to just normalize it. Okay, fine. So train underscore path underscore t1 is equal to scalar dot transform dot fit underscore transform. It was so transform. It transforms the image, and it's as a scalar will transform the image to between 0 and 1. So that's good. It's going to normalize the image. But the more important thing is that scalar cannot transform 3D images. So you have to convert this 3D image to a 2D image, then you have to reconvert it into a 3D image. How to do that? Yeah, we can do this reshape. Train path T1 dot reshape. So we don't know the first, in reshape function we can use if you have to change it in 2D matrix, one thing we can say that we want to keep this thing as constant, because like it should be of different layers, right? Like different patients images should not mix up, so we want to keep that dimension constant, same. We have to change this dimensions to like this 2D into 1D actually. Okay, so it's like a 2D image, but if you just consider 2D image, we want to keep it 1D, and then we want to keep 155 of them, so that each patient, not one patient, one image of one patient should be represented, at least can be represented in one matrix, one row or column, row actually. So for that, what we will do, we don't know how many rows are required, so we will going to put -1 here, and then we are going to keep the second, we want to keep 155 as the same. So what we'll do, we will write train path underscore T1 and -1. That -1 gives us, sorry, not -1, dot shape -1. Then -1 gives us this 155. So here -155 will be put, and then what we will do, we are going to reshape this whole thing. Now the 2D matrix is transformed into 0 and 1. It's normalized. Then we have to reshape this 2D matrix into 3D matrix again. So we want to reshape this again. Reshape this again. Actually, what we'll do, put brackets here. Yeah, reshape this again into its original shape. So the original shape of this. Yeah. Here, yeah, into its original shape. I think this should work, right? I think this should work. I think there should not be an error. Let me check it, as if like might not give any error, but there might be some problem inside it. Like, I think it's okay. Yeah, I think it's okay. Yeah, I think it's okay. So it was the T1. So next we will do T1 CE, T2 and fair. Right, we'll do this fast. What I will do, I will copy the whole thing and put it here. Then put CE here. Then put CE here. Then put, I think, what was the image name? It is T1 CE. That's nice. That's nice. So we're going to put CE here. We're going to put CE here. We're going to put CE here. Put CE here. And I think we are good. Yeah. Let me do one thing. I'm going to write T1. Sorry. T1. T1C. I think this should work. Yup, it's working. Next we will write T2. I think this should work. Okay. Next what we'll do, we're going to put flare. I think flare is left. 3.5 flare. the name once again. Yeah. Okay. FLIR. Think all is good. Yeah. So every image of patient number 1 is reshaped. Yeah. Now segmentation is not reshaped, not normalized, but segmentation is not required to be normalized because it's a image that we don't have to process, right? So why do we normalize it? Because all the processing will be done using these images, so we don't need segmentation because that will not be required. We'll not be needing that for processing, so we'll not transform segmented image. But what we'll do, we'll load the image. We're going to load the image. Why would not load the image? We're going to load this image. Segmented image. I'm going to write this as ground truth. Yeah, I call it ground truth. So write this ground truth, and or we can write it mask. That's a better word choice. We can write it mask, right? So what we will do, we want to put train underscore mask equals to put SCG. Yeah. Next, what we will do, we're going to put that as a unit 8, right? As okay, fine. That's a special type of numpy array. So we're going to put this as train underscore mask is equal to train underscore mask dot as type np.unit 8. Sorry. Sorry. INT8. Yeah. Okay. That well and good. Next, what we'll do, we will see that what are the values that are present in the matrix in the mask. Okay, so yeah, let's see this. What are the values that is present? So in the print np.unique, that give us the unique values of the matrix, because it should have 2 or 3 I think three unique values, because the background, the brain that is not affected by tumor or and affected, that should be 3, I think. Let's check it out. np.unique train underscore mask. Okay, there are 4, 0, 1, 2, 3, 4. Maybe there are 2 kind of tumors, I don't know. Maybe there are 2. I think I should read the cackle once more. Anything written here? Nope, nothing written here. I think I don't know. I think there are different types of. Okay, we'll see that later. When we print the mask data, we can understand in a better way. But for now, we want to just say, okay, one thing. There's 0, 1, 2, and 4. There's no 3 here. So what we can do, we can change the 4, because if we keep that like that, there might be some problem later on. So what we'll do, we'll change that 4 to 3. Okay, so all the 4s in that matrix will be changed to 3. So it won't create any problem because unique, as they are unique numbers, the images will be segregated properly. But just for maybe further calculations, it will give us benefit for further. I don't know why it is given 4, but we'll keep it 3, right? So what we'll do, we will put train underscore mask train underscore mask equal to 4 is equal to 3. This will change all the values in the matrix that are given as 4 to 3. So okay, now let us print this again. See, it has 0, 1, 2 and 3. There are 4 unique values in the matrix, that is 0, 1, 2 and 3. Okay, so this is for the ground truth. Okay, so till now we have I'll keep this video till here. In the next video I want to show how to print the images. Till now we have we know how to extract nifty files and normalize them, and we have changed the mask level from 4 to 3. That's it till now. In the next video I want to print the images of the BraTS of the BRAT files, like of the T1, T1CE, T2 flare, and also the mask. So we're going to print those images in the next video. See ya.
Please subscribe.